Everyone, my name is Derek from Group 6, Session 4. So today our group is going to introduce and explain about the ALU design that we have simulated in the quarters prime. So this is basically how the block diagram of the ALU design look like. I know it seems like very complicated, but yeah, don't worry because it actually built by a combination of different logic and also arithmetic circuit. Okay, as you can see, this ALU system consists of two 4-bit 4 to 1 multiplexer, 4-bit adder and subtractor, and one register. So now let us move on to the multiplexer first. Okay, so this is the 1-bit 4 to 1 multiplexer, and as you can see, we got four input here, which is A0, A1, A2, and A3. And we also got two selectors, which are S1 and S0. So basically, how this multiplexer work is if we selected one of these four input as our output, depends on our selector value. So for example, when our S1 is equal to 1 and S0 is equal to 1 also, it will select A3 as our output. Okay, so now we have done our 1-bit 4 to 1 multiplexer, and now our task is to select a 4-digit number. So we must use this 4-bit multiplexer to implement a 4-bit multiplexer, and this counts. So yeah, this is our 4-bit 4 to 1 multiplexer. Yeah, I know it looks like a much more complicated, but actually it's just built by four 1-bit 4 to 1 multiplexer. So as you can see here, we got four block diagram. So each of it is basically a simplified 1-bit multiplexer, and this time our input have 4 digits. So each digit will be transferred into each multiplexer, and each output will be combined again, and finally we can get a 4-digit output. Yeah, so this basically how our multiplexer works lah. Okay, so back to our final ALU design. We got two 4-bit multiplexer here, so we will select two of the 4-digit number and send this to the 4-bit adder and subtractor lah. So now we are going to explain this adder and subtractor lah. So we start from this easy full adder first. So basically we got two input and one Cin. Cin will stand for carry, and we have one sum output and also Cout. So just give a simple example here. So if 1 plus 1, we got our sum equal to 0 and carry equal to 1 lah. So this is just the basic, and now let's move on to the 4-bit adder and subtractor. Okay, so same here. We got 4-digit number, so we need to have four full adder. So each of the block diagram here is stand for one full adder. So normally, if you still remember, if we want to carry out A plus B, we need our first Cin equal to 0, and if A minus B, our first Cin should be 1. So that's why we have a C input here to allow us to choose whether we want to add or subtract. And the final answer will be sent to the sum output here. However, our task instruction is opposite as what we learned. We need to obtain A plus B when first Cin equal to 1 and A minus B when first Cin equal to 0. So that's why, back to our final ALU design here, we need to put a NOT gate in our Cin input here so that it able to carry out our opposite operation lah. Okay, so now let's move on to the last one, which is register. So basically, this register is a D flip-flop. So same here, we have 4-digit numbers, so we need to have a 4-digit flip-flop. So this triangle symbol is clock, and when our clock input have a rising edge, which from low to high, it will test the value from the D input and holds it until the next pulse. And here, we got our reset also, and this reset is inverse because it have a small circle here. So basically, when reset equal to 0, it will match all the output to reset also, which will become 0 lah. Okay, so that's all for our explanation of ALU design. So now let's move on to the waveform simulation result. So we have already simulated for our waveform result. So let's check. A cell here is selected. So when we A cell equal to 0, 0, it is selected A0, and B cell equal to 1, 1. So it will select B3. So ALU of B here is 0, so it will be A minus B. So 0, 0, 0, 0 minus 1, 0, 0, 1, it will get 0, 1, 1, 1. So as you can see, why here is 0, 0, 0, 0, because the clock is not having a positive edge. So just after the clock is rising, then the output will change to 0, 1, 1, 1. So let's check another value. When A cell equal to 0, it will choose A2, and B cell equal to 0, 1, it choose B1. So ALU of P here is 1, so it will be A plus 1. 1, 1, 0, 1 plus 0, 1, 1, 1, we get 0, 1, 0, 0, correct. And as you can see, when reset equal to 0, all our output will become 0, 0, 0, 0. Okay, so I think that's all from me today. So if you want, you also can try with different value to check our answer lah. But yeah, bye bye everyone.